Hello all, welcome to my YouTube channel. This is part 2 in the foundation LLM fine tuning with QLoRA. So in the last video, we talked about how we can like what is the concept behind LoRa and quantization for LoRa, right? So yeah, in this video, let's get our hands dirty and try to understand how we can do the coding part, right? So to start with, this is the I have done this coding in a Kaggle kernel. So I will share this link in the video description of this video. And so yeah, let's get started. So at first, what we will do is we will do the installation of the required libraries, right? And so like one of the important libraries like PEFT. So using this PEFT only, we will do the parameter efficient fine tuning using the concepts which we learned in the last video of LoRa, right? Then bits and bytes, which is again a library from Hugging Face, which will enable us to load the quantized version of Llama 2. So in this tutorial, I will be using the Llama 2 foundation model, and we will try to fine tune the Llama 2 foundation model using the concept of LoRa. And then we will use this transformer, which is from Hugging Face only, and also the TRL, which will help us to do the supervised fine tuning, right? Okay, now after that, like some boilerplate code, which I will not go through. These are related to weights and bias configuration and all. So the data set which we will be using for this video, right? So we will use this dialog sum data set where there are like 4 features which are present. So you can go ahead and open this URL and you can get an overview of this data set, right? So this is how the data set looks like. We have an ID column, then there is a dialog column, which is like a conversation between two-person, and then there is a summary of that conversation. And also you see there is a topic associated with this conversation. But our interest of columns are dialogue and summary. So what we are trying to do using this using in this session is we will try to fine tune the foundation Llama 2 model, and we will fine tune it for the text summarization task, right? So we will create LoRa adapters for text summarization task on top of this data set, right? So once we like mention the dataset path, and then we can use this load dataset from Hugging Face to load the data from Hugging Face, right? Once we load this, you will see like the data will be downloaded for the first time. And we have 3 datasets, which are like train, test, and validation. So I will only load the train and a set of rows from my test data set, right? So that I am calling as train DS and test DS. Once that is done, so what I will do at first is we will convert this Hugging Face data set to Pandas data frame. Now, why we are doing this? This is because we want to create our prompt in such a way that it follows the prompt format related to Llama 2, which is again we call as alpaca format, right? So we will see like how this format looks like. So this is, I have created a prepare dataset function which takes in the data frame and also the split on which the dataset is for, like whether it is a train set or a test set, right? So this the dataset format will be like this. So it will have 4 parts. One is like our 4 pairs, which would be incorporated in this each of the data frame rows, where the first one is like instruction, but the instruction is like write a concise summary of the below input text, return your response in bullet points, which covers the key points of the text. So we are giving an instruction to the LLM, and based on that instruction, the LLM will try to do the task, right? So the instruction, so the 4 things which I mentioned, right? So this is like the prompt which will be passing that will be passing to the model LLM model, and then we have our instruction which we have defined here. Then we have the input, right? So input is nothing but our dialogue, right? And the response is we will also get it from the data frame which we have. So we are doing a df.iter rows. From each of the rows we are kind of fetching the dialogue and the summary. And we are kind of using that while forming this text, right? So we have prompt, then we have instruction, then we have input, and we have also have the response. So in case of training data set, we are keeping the response. So I am at first you will see like I'm checking if the split is trained, right? So then only I am putting the response in the text preparation step, right? But in case of test data set, I'm keeping it blank, right? And the formats which you see here, like this hash, hash, hash. So this is the alpaca format, which using this format only, the Llama 2 foundation model was trained, right? So we are just maintaining that format, and we are creating a data set in that manner. So at first, like I'm calling this prepare data set function with train df and test df, and we are also mentioning the split for which we are calling this function, right? Train and test. So once that is done, our train df and test df will be created. Now, if I just want to look one of the example from my training data set, right? So this is how it looks like. So it starts with an instruction, then with a new line, the input starts, right? So after giving the input, we are also giving a new line, and then this whole text is given, right? Which is coming from the source data. And based on this, we also have a response, which is kind of a summarized task of this whole conversation that is happening, right? So this is kind of the summarization of this whole text, right? And if we look into the test, one of the rows from the test data set, we will see I have created in such a way that the response is blank, because we will pass this test data set after doing the fine tuning. We will pass this test data set to the LLM, the fine tuned LLM using QLoRA, and we will see the response, how it is, the response is properly formatted and properly it's working or not, right? Then we are converting our pandas data frame to the data set. So in between, like we started with Hugging Face data set, then we converted to a pandas data frame to do the to create the data set in this specific format of prompt, instruction, input, and response, right? So once that is done, we will convert this back to the data set, right? Which is a Hugging Face data set. So what I'm doing is data set from dataset dot from pandas. We are passing the data frame related to train dataset, and we are getting back the Hugging Face dataset format, right? So once that is done, what we will do is we will load the foundation Llama 2 model in quantized format, right? So few of the libraries which will help us to do that is one of is like from transformers, we will import like auto model from causal LM, because we are this is like a causal LM language modeling we are doing. And also we will import like the auto tokenizer bits and bytes config from the transformers, right? So bits and bytes config will help us to create the configurations which are related to quantization, right? So, and we are using a sharded version of this Llama 2 model. So this sharded versions is nothing but the model is kind of which is divided into different shards, and it will be kind of helpful for distributed training for large LLMs, right? Like where the size of this Llama 2 7 billion parameter model is quite large. So it will kind of created small shards out of this. And during training, it will help us to like distribute the model parameters, gradients, and optimize the states across the different machines, right? Or different cores of my machine, right? So if you see, and then what I'm doing is I'm creating a quantization config. So here I'm mentioning what is the config, what is the quantization config that I need to have. So if I just go to this link, sorry, this one. So you'll see this is where this is a Hugging Face tutorial from Hugging Face blog, and it mentions that based on like theoretical consideration and empirical results from the paper, we recommend using NF4 quantization for better performance, right? So we are doing normalized float 4. We are using this NF4, which is nothing but normalized float 4. And we are using this for like from this experimentation, Hugging Face is kind of suggesting us to use this, which will kind of give us better performance, right? And also, if you go back to this configuration, we will see that the compute D type is float 16. So all the metrics operations that will happen while doing the fine tuning, right? So that will happen at this float 16 precision, right? So the two things which we are mentioning is like the bits and bytes 4-bit quant type, so that is NF4, and also the compute data type, which will be used during the metrics operations while doing the fine tuning of the model, that is float 16, right? Then we are kind of loading the model, and while loading the model, we are passing this BNB config, right? Which is like the quantization config, which we are passing. And also we are mentioning device map equals to auto. So it's like the model can switch from CPU to GPU and vice versa based on the availability of the resources, right? So once that is done, you will see like the all the sharded version of my Llama 2 model, right? So there are 16 shards which are there in this model. So that each of these shards will be downloaded like in parallel way, and then the model will be loaded into the memory, right? Once that is loaded, we can create the Llama 2 tokenizer out of it. So using the same model name, we will create the tokenizer for this. And we will also mention the padding token is nothing but the end of sentence token, right? So this is a critical step which you need to mention here. What would be the padding token for this tokenizer? Like, so that is the end of sentence token or the EOS token, right? So once that is being done, now we will start building the QLoRA configuration, right? So in QLoRA configuration, if I just print my model, right, you'll see like all the layers of my models. You can see here like this QProj, KProj, VProj. So this is like QKV from the attention mechanism which that is being used in case of Llama 2 also. So those layers we can see here, right? So we will select certain matrices which are related to this Q, K, and V, and we will only create adapters for those specific layers, right? So here, if you see, so I'm mentioning the LoRa alpha as 16 and LoRa rank as 8. So that is the rank which we are using to using this PEFT model, right? We will mention what is the rank which we are using. So if you remember in the last tutorial, we mentioned like we will create low rank adapters for particular matrices. And by doing the matrix decomposition, while doing the fine tuning, it will create matrix decomposition, and using the low rank parameterized matrices, it will do the fine tuning. So here I am mentioning my target modules, right? So it will create adapters only for Q and V matrices of attention module, right? So QProj and VProj I have mentioned here. So using this config, your the parameter efficient fine tuning will work, and it will only create adapters for my Q and V matrices of attention module, right? And also I am passing the LoRa rank here. So it will do the matrix decomposition, and it will create low rank matrices based on rank of 8, right? So once that is done, then we can start creating the training arguments. So these are like the regular training arguments from Hugging Face. So the few things which you can look into the Hugging Face document is, so you can look into this Hugging Face documentation. So all these links I will provide in the description of this video. So one of the thing which you should look is like, what is this per device train batch size, right? Which I mentioned 4 here, and also the gradient accumulation step. So you can go back to this documentation, and you can read out this thing, right? So which is like per device train batch size is nothing but the batch size per GPU, or in case if you are using TPU or CPU, what would be the batch size per GPU, right? So if you are using multiple GPUs, then it can have a distributed training, and based on that, the batch size will be used according to the value that you have mentioned for this parameter, right? Then there is this thing, the gradient accumulation step, which is nothing but number of update steps to accumulate the gradients for before performing a backward or update pass. So for the value which we mentioned here is we mentioned 4, right? So it will kind of accumulate the gradients for 4 steps, and then it will do a gradient descent steps to optimize my model parameters, right? And also I'm mentioning FP16 equals to true, which will take care of the quantization part. And all these parameters which are there, you can go back to this link and you can read through what are these if you're not understanding any of these parameters, right? So once that is the training arguments are created, then using this SFT trainer, which is like supervised fine tuning trainer. So this is where like if you have your data set in Hugging Face dataset format, then you can use this SFT trainer to do a faster training of a faster fine tuning using the supervised fine tuning concept. Right here, the important thing is this dataset text field. Right, so we are mentioning our dataset text field. So in our dataset, which we are using the Hugging Face dataset format, right, on which column it should look to get the instruction, right? So it's we are doing an instruction fine tuning, so it needs to know on which column it should look to find the instruction and the corresponding response for doing the supervised fine tuning process, right? And we are also mentioning the PEFT config here, and also we are passing the training arguments which we have created in this section, right? Apart from that, we are also passing the tokenizer inside this, and also we are mentioning what would be the maximum sequence length, right? And once that is done, so in the Hugging Face document, it is also mentioned that we need to upcast the layer norms into the precision of float 32 for stable training, right? So that's why I am also using that in case of this QLoRA fine tuning also. Once all this is done, we just need to call this function trainer.trend, and it will uh, click on the fine tuning process, and it will also give you what is the training loss, right? And you'll see like the training loss is decreasing with the number of increasing steps. So the training is happening properly, and your model or the Llama 2 foundation model is kind of getting fine tuned for the specific data set on which we are working on, right? So once the training is done, what we will do is we will save this to our output folder, right? So we are naming this folder as outputs, and there I am saving the model. So these are like the LoRa weights or LoRa adapters, which are like low rank adapters, which will be created, and the size of this would be very minimal, and that will be get saved to this folder, right? So once that is saved, so now we can add back this LoRa adapters to the base foundation Llama 2 model, right? So how to do that is at first we will read that output folder using this LoRa config dot from pre-trained, so that we will use this to read the LoRa config from this output folder, and then we will using this method which is like get PEFT model, we will pass my base model and also the LoRa config, right? So this two will be added back and we will get the final model, right? So let's look what this output folder holds, right? So if you check at this output folder, you'll see like there are certain configurations which are being created once the fine tuning process is done. One of them is like adapter config.json file, and there also a model bin. Also, there is a adapter model.bin file which has been created here. So all this will be kind of read back and will be added back to the base model of Llama 2, right? So once that is done, what we will do is we can start making inferences on my test data set, right? So just picking up a random example, like this is like the first example from my test DF. So this is how it looks like. And here you see we do not have the text associated with that. So this is some conversation between employer with his employees, and they are mentioning that the instant messaging tool will be blocked during the office hours, which is kind of a very harsh thing to do. And so if I pass this as an input to my tokenizer, so at first we need to tokenize our this text. So we are using the tokenizer which we created previously, the Llama 2 tokenizer, and then we are passing this text and we are returning that it should be a PyTorch tensor, right? Once we have that, so that is like the tokenized version of my input text, and then we will pass this input to the model, right? So what the function we will call is model.generate, and here we will pass the input IDs and also the attention mask along with the number of new tokens we wanted to have while generating the text, right? So we are mentioning as 100, and also we are making repetition penalty equals to 1.2. So this is kind of an important parameter that you should write while making the inferences. If you don't write it, it can be seen that it kind of generates the repeating text in the output, right? So once that is done, the output is kind of generated here, and then we will try to decode it using the tokenizer, right? So at first we encode the input text to using the tokenizer, then we pass it through the model to get the outputs, and then we need to convert it back to the actual text, which is like human readable English text, right? So that we are decoding here, and we are printing the output. So this is like the input to the model, and in the end we are getting a response out of it, right? So if I just read out the response, it talks about like the company has decided to ban instant messenger for its offices because they waste too much time, right? It looks like a very harsh manager of this company is kind of having a conversation with his employees, right? And it is also mentioning the key point as employees can still send emails or write letters instead if someone uses IM. IM is nothing but instant messengers anyway. He or she would be warned once, then they would be fired if they caught again. So it's kind of a funny thing, which is like the conversation between the employees and with his boss. And we can see like Llama 2 is kind of capturing the essence of this conversation, and it's kind of giving you the crunch of or the core essence of this whole conversation, right? So similarly, I have picked up another example, and if I just read through this, this is kind of a very interesting thing which we'll see, right? So there is a conversation between two persons, and I was quite surprised to see that Llama 2 is also kind of picking up the emotions that are going on inside this conversation. So if I just read this for you, like the person one wants to know what happened before they started filming, right? And then the person two thinks person one should show more emotion because their characteristics are supposed to be angry at each other, right? So these are like normal conversations. So the last line is kind of bit of interesting one where the person was says that men usually don't express much emotion after breaking up with someone, right? So it's quite funny how the Llama 2 is kind of picking up this emotion which are related to men, and then they are saying they just go through the emotions until they really feel bad, right? So this is kind of quite interesting how the Llama 2 is kind of picking up those things, and it is kind of giving you the output, right? Um, so yeah, that's all I have for this video. I will mention all the links which I talked about, and also the link to this the Kaggle notebook which I have written. I hope you found this useful. So if you like this, please subscribe and share this video with your friends and colleagues. Thank you all. Thanks for your time. See you in the next video.